34 here. So we'll come back to those notes in just a moment. So we're asked to find direction and magnitude. For me, finding direction is a little bit easier if I make a sketch of it. So 34, I made a sketch. I created a right triangle, basically a reference triangle, and then I'm going to find my reference angle using a SOHCAHTOA right triangle trig equation. Keep in mind when I solve for this theta, though, that's not going to be my answer. Unless otherwise stated, we want to measure angles from the positive x-axis. So whatever I get for theta, I'll do 180 minus that. And that'll give me my final answer. So to find theta, I need to set up a tangent equation. Tangent is opposite over adjacent. So then we use an inverse tangent to get theta. And then whatever we get for that, punch it in the calculator. I guess I might as well. Here's tangent 2/1. 63.4 degrees. So 180 minus 63.4 would be, oh, somebody with some good mental math skills help me out. 116.6 sound right? For the magnitude, we could just use the magnitude formula. -1 and 2, so that's 1 plus 4, so √5 for the magnitude. Any questions about 34? Oh, someone asked about it. Well, you know what? I think I may have put something different in Canvas than what I put on when I wrote for you guys, because I didn't have my notes because I gave it to you guys. So maybe some people did it. Either way, you did a selection of the even numbered problems. I think I may have swapped a couple. All right, 44. I think I assigned 44 to. We all did 44, right? That was the flight piece. So 44. So I'm gonna try and visualize this graphically first, since we spent so much time on that on Wednesday. So an airplane is flying on a compass bearing of 170. So remember, north is 0. So south would be 180. East is 90. West is 270. So 170 is going to be pretty close to south, a little bit east of south. Agreed? So the plane is flying that direction, 170. And where are we at here? I lost it. At 460 miles per hour. And then we've got a wind blowing at a bearing of 200. So 200 degrees is going to be a little bit, it's a little bit past south. It's a little bit west of south. And it's blowing at 80 miles per hour. So it's going to be a much shorter vector. So what they want us to do is, well, we're going to find the resultant vector. So we're just going to add those two vectors together. So if I put them head to tail, then that's going to be my resultant vector. That's what it's going to look like graphically. Now, the only way we can do this is to come up with the, we're going to need to come up with a component form for each of them. So I'm going to sketch them both on an XY axis. So one of them was heading at 170. It's pretty close to 180. So if I were going to do this with a reference triangle, I would need to figure out what this is. How far is 170 from 180? 10 degrees. So this would be a 10-degree angle here. No, this wouldn't be at 10 degrees. What would it be? It would be 80, wouldn't it? Oh, that's terrible. That's an 80-degree angle. This would be the 10, right? So that would be 80. So our X and Y components, I don't think they're both going to be positive. Which one's going to be negative, the X or the Y? The Y will be negative. X should be positive. And to find the magnitudes for the X, we'll just use the cosine, and for the Y, we'll use to find the components, we'll use cosine for X and sine for Y. And we need a magnitude. It was flying at 460. So we get those components. Then I need to do the same thing with the wind. So let's do that. The wind was blowing, was at 200, so that's a little bit past 180. So this would be 20, but if I made a reference triangle, that would make my reference triangle have a 70-degree angle in it. Oops. Move that so we can actually see it. So now my reference angle is 70 degrees. So same idea. We're going to make a vector out of that. Tell me about the X and Y components. Are either of them negative? Both of them are negative. Negative, negative. And to find the X and Y components, we'll use the sine and cosine. Angle is 70. And how fast does the wind go on 80? Thank you. It's sine twice. The X should be cosine. All right, so we got our components. What are they asking for? They want the component form for the airplane and then the ground speed and direction of the airplane. So we needed this was part A, but we needed this to get part B. So I'm not going to go through and do part B for you, but you need to add these two vectors together and then find their direction and magnitude, which we just went over an example of how to find direction and magnitude for a vector up here. So this one's going to have bigger numbers and some decimals, but you got this. You can handle it. What other questions did you have from the assignment? How are you guys feeling about vectors so far after one section? Do you like them? Do you hate them? Do you think they're useful? Oh my gosh, they're so useful. So useful. Anybody in here into like art and design? I think you might have a future doing designing logos and advertisement, that kind of stuff. There's a whole lot of money in that. You ever heard of vector graphics before? So what's the difference between like a JPEG and a vector graphics file? You know? So if I have a logo, if you want to make a company logo, usually you make a logo using a vector graphics file. So I maybe I can look and try and find something later, but a vector graphics file, you can zoom in as close as you want on it and it will be crystal clear. Because it doesn't store an actual image, it stores an equation that tells you how to draw all the lines in the thing. And you can zoom into that as close as you want because the computer is able to zoom into that equation the same way you can zoom in on Desmos. right? Where if you make it an image file, if you zoom in, it's going to get it kind of pixelated and blocky, kind of Minecraft looking. So, but that's just one way. You can make really pretty art with vectors. I'll show you some examples next week. Okay, we got to move on though to 6.2 today. This is a nice, relatively short and relatively straightforward topic today.